Alright, so what we're going to be doing is, this is geometry, and you need to make sure you've got the book. If you haven't gotten the book yet, you need to get it from me. This is the book I use because it's a good pre-Common Core standard public school textbook. But also one thing that's really good about it is that it's not just lesson after lesson. It's got good dimensions to geometry in it, like the drawing labs. You're going to have to draw. Yes, this is the one math class that combines logic, art, and math. Yay, that'll be fun, right? Alright, so what we're going to do today is we're going to first talk about, section 1.1. So you need to have your book and follow along. I know some of you don't have your book yet, but that's why I'm going to give you 2 weeks to watch these videos, get your book, and us kind of get it all together. And I'm going to give everybody 1 extra free week because it's taken us a while to do the, figure out how to make the switch from Facebook to YouTube. Hopefully it'll all be good, and this will be much better in the long run. Just a little bit of growing pains right now. Alright, so let's talk back about what I was saying about geometry. That it is a little bit of a drawing class. So the way this is going to work is I'm going to have you watch your videos on Monday, and then you will have assignments to do on Tuesday, Wednesday, Thursday, and on Friday it's your drawing lab. Your drawing lab and your test you will snail mail into me. You will put them in an envelope and mail them through the United States Post Office. Regular homework, Tuesday, Wednesday, Thursday, you're going to take a picture of it and you're going to email it to me. And I'm going to give you that email address when I give you some homework, which I haven't done yet, so I haven't given it to you. Alright, so turning your book to page 3, and we're going to talk about the first section, 1.1. Each video is going to be a separate section. So, you know, if a chapter has 6 sections, you'll watch 6 videos on it. Sorry about the drinking. The water. Okay. You know, I lost my pink bottle that we had at the library this year. Irritated that for those of you who had me last year. Okay, so look on page 3, and you can see that there we have, for example 1, we have some patterns. And I want you to cover up the solution and just look at the problem, for example 1, and you see 1 box, and then you see 3 boxes, then you see 6 boxes, then and it goes on like that. So looking at that pattern, I want you with it covered up to see what you think the next shape would be. Has everybody thought of that? Now uncover it, and you can see that it had, where the first one had 1 across the bottom, the second one had 2 across the bottom, third one 3, fourth one 4, fifth one 5, the sixth one has 6 across the bottom. So trying to figure out patterns is something we are going to do both in geometry and next year in Algebra 2. So make sure that, you know, we start thinking about patterns in numbers. So you can see that. So that's pretty logical. Okay, so let's try the next one. Look in your book for example 2, and the pattern is 1, 4, 16, 64. What do you think the next number would be? 1, 4, 16, 64. Each one is 4 times the one before. So 1 times 4 is 4. 4 times 4 is 16. 16 times 4 is 64. So the next one is 64 times 4, which is 256. Right? Look at the next pattern. It's for B. It's -5, -2, 4, 13. Any guesses? Don't look yet. Any guesses of what the next one would be? For each one, you add 3 to get to the second number, 6 to get to the third number, 9 to get to the next number, 12 to get to the next one. So which one are you, what are you going to add to the next? You're going to, well, I just said the answer, 12. So the next one would be 15. So they were counting by 3s and adding it to the previous number. And, you know, to count by 3s, you go 3, 6, 9. 12, 15, 18, 21, 24, 27, 30. That's from Schoolhouse Rock. All right, so what we're doing right now, looking for these patterns, are the logic part of geometry. So part of geometry is logic. I know some of y'all do logic classes in homeschool. Some of you might not. That's okay. You're going to do some logic here. All right. The next thing, turn to page 4 in your book, and we're just going to look at a couple of words, okay? And this is talking about our logic and our reasoning. So whenever you have a logic problem like that, sometimes you look at it and you just, boom, see the pattern really quick. Other times, you have to kind of sort of go through steps. And those steps are at the top of page 4. Look for a pattern, then make a conjecture, which means think about, well, it seems to be, and then think about what that conjecture is. And then go ahead and try the next answer. See what the answer would be if your conjecture is right. And then what I want you to do is look in the back of the book, because the answers are there. For your homework, I'm only going to give you the odds, and the answers to the odds are in the back of the book. So that's what I want you to do. I want you to give it a try and then look. If you still don't understand it after you look, you can text me and I'll try to answer you. And a lot of times I'll answer with a video, but I'll probably answer with videos on Facebook Live and not go through the YouTube thing because it's hard. All right, look at example 3. We're going to complete the conjecture. The conjecture is the guess of what you think is going on. The sum of the first n odd positive integers is. That's the conjecture. Now, let me explain to you what that means. When you were in algebra, we used x to stand for an unknown integer. Now that you're in geometry, will use n to stand for an unknown number sometimes. So that's why they're using n for number instead of x. X is integers, and these numbers are integers too, but we'll just use n when we're looking for these pattern things. It's just a little probably math etiquette thing. All right, so what they did is they said the first integer, the first odd integer is 1, and 1 is the same thing as 1 squared. The sum of the first 2 positive integers are 1 plus 3 is 4, and 4 is 2 squared. The first 3 odd integers are 1, 3, 5. If you add them up, they're 9, and 9 is the same thing as 3 times 3, or 3 squared. And then the next one, the first 4 are 1, 3, 5, 7. You add them up at 16, and 16 is the same thing as 4 times 4, or 4 squared. So that was just a pattern, and then their idea is that the sum of the first however many number of odd positive integers is that number squared. And so that was just a little guess about this pattern. Now, if you try this and you keep going and going, and then you find one situation where it's not true, that's a counterexample, and that means it's not true. It's like an experiment where you're doing your experiment and then you find out it's not true. You have to discard it and get a new hypothesis. Okay? Look at example 4. There they're showing a counterexample. Their conjecture was for all real numbers x, the expression x squared is greater than or equal to x. And so like 2 squared is 4. 4 is more than 2. So that seems to work, but it's not true, because if you had negative 2 squared, negative 2 times negative 2 is positive 4. So it makes it where the numbers don't, not negatives, because that would be true. It's fractions. If you take a half times a half, that equals a quarter. And a quarter is less than a half. It's the fractions. It's a different one I was thinking of. I said it wrong. All right, look at example 5. Here is a conjecture in the early 1700s. A Prussian mathematician named Goldbach Notice that even numbers greater than 2 can be written as the sum of two prime numbers. Remember, things that don't have factors other than itself and 1. And so they kept trying it over and over again, and they've never found a counterexample. Now they have computers working on it. It was still found to be true. When I last checked on the internet last fall, I think, still true. And now they've confirmed it 4 times 10 to the 18th power. So I think it's true. I don't think they've got computers trying to prove his conjecture still. Looking for the counterexample, and they never can. Look at example 6. We have moon cycles. And they're making a conjecture about how often the full moon occurs. And they decided it was every 29 or 30 days. It's true. The full moon is every 29.5 days. All right. So that is section 1.1. And we will be doing, I'll be giving you homework on it. So stay tuned for that. Math is fun.